Assalamu alaikum dear students, I am Engineer Abdul Basit and we are in week number 8, lecture 16, okay, of the subject hydraulics. So this is basically the second lecture of this week. The topic is hydraulic structures, okay. In hydraulic structures, particularly we refers to that dam structures, that well structures, barrages, okay, and head regulators, all that type of structures which are basically the uh, water storage structures, okay. So in previous tutorial we have discussed about the weir structures and the main components of weir, that was demonstrated with the help of a model, okay. Now here we will see all the practical cases, how these components work, and what is the real model of those components of the weirs and dams. It is worth mentioning here that the different types of components that we have discussed in case of weirs are also applicable in dam structures, okay. And all the components are having their own function, okay. So first of all, coming towards the dam structures, the main idea of it, and then we will discuss about the different types of purposes for which the dams are constructed. We will discuss the advantages and disadvantages of it, and components of it, and we will see some practical pictures, and we will discuss different hydraulic structures as well, okay. And we will try to cover this a whole tutorial in three parts, or in two parts, okay, to keep it limited to 20 minutes videos, okay. Here it is, the dam structures. First of all, definition. So coming towards the practical view of it, here we can see this is a dam structure. On the upstream side, the water is coming in the river, okay, and here it is a barrier, that is a concrete dam, okay, a concrete barrier, which is consisting of two parts. One part of it is completely solid part, and the other part is having gates and buffer walls, okay, where we can discharge the stored water in the reservoir on the downstream side. And there a third part is also located over here, which is the fish ladder, okay. This is basically constructed for the movement of the fishes in on upstream and downstream side of the river, okay. So as we have provided a barrier for the flow of water, so similarly this barrier is equally applicable for the motion of the or movement of the fishes as well, and it's restricting the movement of the fishes, which is particularly in the winter season from the upstream side towards the downstream side of the warm water. And then in the summer season, the fishes tends to move or shift from their migration is from the downstream side towards the upstream side, near to the hilly region from where the water is coming, okay, as the water in the downstream side will get dried with the passage of time, okay. So that may be the case, okay. The fishes migrate for its food, for its particular warm and cold condition according to its body temperature, and that movement may be for the availability of deep water as well, okay. So that is possible with the help of this fish ladder, where the velocity of the water is decreased, okay, or maintained to a low velocity, so that the fishes can move upward and downward. Here it is that concrete dam, okay. You can see all the rest of the structure is constructed with the help of from the brick, from the earthwork, and only the part where the gates are located are constructed with the from concrete, okay. Here it is a concrete dam. You can see the spillway and the regulators as well, and the gates as well, okay. And there is a bridge to move across the river as well, okay. Here it is the same structure, okay. We can see the gates here, and this is the divide wall, okay. Under sluices, that fish ladder, and similarly this is that Hoover Dam, okay. That concrete dam, okay, one of the largest concrete dam in the world. The dam is a structure that is built across a stream, a river, or estuary to retain the water. So dam structures are actually simple. In simple words, it is a barrier that is constructed across the river to stop the water flow, to store the water on the upstream side, okay, of the barrier. So that water may be used for the power generation and for recreational purpose, and for irrigation as well. Okay, dams are made up of variety of material that may be from rock, from steel, from wood, from concrete, from brickworks. So different types of materials may be used for the dam construction. So here it is, that top view of the dam. You can see that how much capacity of the water storage is present over here on the upstream side of the dam, and here it is that small construction, okay, and the barrier and bunds are also lined. Okay, so here this is that reservoir, this is their dam part, okay, if it is visible to you, and this is that river that will flow in its original direction on the downstream side. So these are the few colonies where the staff for the dam operation will live in, okay, and some hotels for where the visitors will be using it for recreational purpose. That turbines may also be installed, that power distribution system may also be present over here. Okay, so this is that proper system. Now in the close view, you can see that the parts are like these are the bunds. Okay, this is that spillway which is operated with the help of gates. Okay, this is that bridge over the spillways. This is that tunnel which can be used in case of floods to control the flood system and to divert the water from the river on the downstream side to some other direction where so that we can manage the water that should flow in this river. Okay, and we are having this new inlet channel, okay, that may be used for the power generation penstocks as well. Here it is, that structure of the dam. So particularly this is that core of the dam structure that is made up of maybe of concrete or maybe of anything else, any material may be used, okay, that provides us with the that prevention for seepage. Okay, and then we are having this heel, this is toe. As you can see that the dam structure is constructed in the form of a trapezoid, okay, where this portion is a bit extended, unlike this heel portion. This toe portion is a bit extended. This is for the stability, to provide it some stability, because the water is coming from this direction. Okay, so whenever the water is stored over here, so it will cause some overturning effect on this dam. So to tackle that overturning effect, this part is a bit extended. Okay, much like our sole, okay, our feet, human feet. You can see that this is their toe, okay, from which from the side from where the water pressure is coming, and on the opposite side we are having the toe portion. The sluice ways may be present over here, okay, and this is that gallery portion, which is that main structure, main dam structure or barrier. This is that freeboard which will be used in the form of floods, okay, in the case of floods. Okay, freeboard is actually that empty portion above the water surface, or the natural water surface or full supply level. Okay, which may be used in case of floods. Okay, that will be filled only in case of floods whenever the water is rising above this red dotted line level, that is the full supply level, okay, or full storage level. So then it will be the flood condition, okay, and that water may or may not be allowed to pass above the crest of this dam. Okay. These are those spillways that are constructed above the full supply level, which provides us a way to make the water flow above the full supply level to the downstream side. So this is the detail about those terms individually. Okay, so it's already explained. we are having abutments and diversion tunnel. These are something which is not explained in this picture. Okay, so abutment actually refers to the those structures which are giving us a conversion point of water on the dam, on the barriers. Okay, uh, let me show it to you in practically in pictures, so that will be more clear to you then. Diversion tunnels actually refers to those tunnels which are constructed on the sides of the main reservoir, which are used in case of floods to divert the water from that reservoir for irrigation purpose, from all the purposes to reduce the pressure of water on the reservoir and side bands. Okay, so that may be in this form, okay, in which the water will flow, and it may be lined, may not be lined. Okay, so these are called diversion tunnel. Particularly it is a common investigation that in Torbella Dam, whenever it was constructed in 1960s, in 60s, so it was like the side hills, or you can say the mountains, or the side bunds were shaking due to the full storage of water. So that was a bit of you can say artificial earthquake occurring on the side bunds. So to tackle that situation, it was proposed to provide some tunnels, diversion tunnels on the sides of the reservoir, so that the water pressure may be tackled, or to be maybe able, we should be given some access to control that pressure. Okay, so here are those tunnels which are constructed. Now, advantage of dams. So dams may be constructed for the drinking water supply, maybe for the water supply to the, for the irrigation purpose to the farmers, and dams may be created for electric power generation, or you can say for power generation purpose, in simple words. And dams can also be constructed to control the flood situations. Okay, as we are having we are facing it now and then in Pakistan. So we should have more dams to control that flooding condition, so that we can store the maximum water in case of floods. Dams create lakes for people to swim in, and so it's, in simple words, you can say dam can be used for recreational purpose, for sailing as well. Okay, recreational purpose particularly refers to, it will provide us a spot where the people can come and enjoy, and visitor can come and enjoy and see something different out of the congested life of the cities and towns. Okay. So disadvantages, in parallel to its advantages of many advantages of dam, we are also having some disadvantages of dams. Okay, that should also be considered, and should be we should try to minimize those disadvantages by planning it particularly properly. That is, number one, we are having dam detract the natural settings. Okay, so the natural setting, the natural mountains, the natural bed level, the natural bushes over there, plants, you can say many other things will be, the natural things will be distracted due to dam construction. Okay, it is obvious that we are having some artificial construction over there, so the natural things will be converted to artificial things in that particular vicinity. Then dams have inundated the spawning ground of fishes. So this is like it is for the inhabitants of the river and ponds, the dams construction may affect it adversely. Then dams may also restrict the seasonal migration of fishes, as I mentioned earlier. Dams may deplete some species of the fishes which are unable to move across the dam structures or the fish ladders. Okay, so that species will be destroyed, and we have lost many species of the fishes due to dam constructions in Pakistan and all over the world. Okay, dams may have the enumerated the archaeological findings. So maybe if you are constructed a dam somewhere and you later come to know that there are some archaeological findings possible over there, so that may not be possible after construction of dam. Okay, and then reservoir can cause different types of diseases, different types of that water will be expand on a vast area and will be maybe inhabited for different types of parasites, germs, and etc. That can cause different types of diseases which are not curable nowadays, or may be curable but may be very disastrous. Reservoirs water can evaporate significantly. As you can see in this picture, that the water is like the surface of the water is very void. Okay, so more sunlight will be taken by this water and more water will be evaporated. Okay, so that should also be properly tackled. Some researchers believe that the reservoir can cause artificial earthquake as well, or you can say can increase the tendency or probability of the natural earthquake as well by feeding that lava under the surface of water, surface of ground. Okay, so we are having different types of dam structures. This is that view of the China map. Okay, where we have in the Hubei city a dam is constructed, that is a Three Gorges Dam. Okay, here it is that plane view, or you can say satellite view of that structure. So the magnified form of magnified view of this area, which is inside this that red rectangle, you can see it is magnified in this form, and this white color of the line is showing us the location of the dam. Okay, so on the downstream side, on the upstream side of this white line, you can see this is that whole reservoir. So how this Three Gorges Dam is constructed and what are different components of their dam. So here it is visible in that picture. This is that Three Gorges Dam, which is a concrete dam particularly. Basically, as I told you, there are two parts of it, main two parts. This is that solid part where no water is allowed to pass through it, and this is that part where the water can be regulated to move past the barrier. Okay, and this is the divide wall. Sometime it is constructed on the upstream side, sometime on the downstream side. That may be the case. And here at the ends, let me show it to you with the help of this pen. This portion, in this portion we are having the shipping lock and different types of other micros, or you can say small structures other than these solid structure and these gates. Okay, that are also present over there. So how you can see it from the top view? So this is that model of it. You can see this is that diversion canal, okay, located over here, and this is that shipping lock. Okay, and the rest of the structure is was clear to you. And this is the total data of the Three Gorges Dam. Okay, this was concrete dam. 25 billion is its cost. As I may have mentioned that the Basha Dam that is presently under construction in Pakistan is having a cost about 10 to 12 billion dollars. Okay, so this is 25 billion dollars, and it was this construction was started in 1993 and 2009. So you can compare it to Basha Dam, how much you can say expensive this structure is, and how much a big structure it is. Okay, a huge structure it is. Power generation capacity here it is 18,000, and in Basha Dam we are having it almost 4,500 megawatts. Okay, and this is the length of the reservoir. This is that square kilometer of the land which will be submerged, and this is that level 175 meter above the sea level. It will store the water. And navigation, so two-way lock system become operational in 2004, in which you can say the ships can elevate due to it and can move across the reservoir or barrier. Next we are having this view of the Three Gorges Dam. These are those under sluices. So you can say these are those gates which are like buffer walls are constructed. These walls are called buffer walls, and these are those regulators that you can say gates which can be kept open and closed. And you can see the water is coming out in the lower region, which are the under sluices. Okay, and these under sluices are particularly used for the silt extraction from the dam on the downstream side of the river. Okay, so I have mentioned it in the previous few slides. Okay, this is that shipping lock. So already I have told you in the detailed view of that picture, which is that small structures are shipping locks, which are particularly used for the movements of the ships across the barrier. Okay, so these are those gates which can be kept open and closed, and the water flow can be regulated over there. So of a particular size of ships can move through these shipping locks. Okay, these gates may be kept open, may be kept closed for the movement of the ships. Hoover Dam. If you are a movie freak, you may have seen this Hoover Dam in Doom 3 picture movie, in which the last scene, okay, in which Amir Khan is jumping down from this structure. Okay, and the last scene is picturized over here in this Hoover Dam. So if I'm not wrong, this is their same dam. Okay, these are those that penstocks. Okay, these are those penstocks. In which the water will these tomb type of structures will intake the water from this reservoir, and will take it down to these structures where the turbines are present, and the power is generated over here, and that power is then transmitted through these power transmission lines, okay, to the community. Okay, and these are those overflow tunnels, okay, which can be used in the form of floods when water level rises over here. So this tunnel will come in operation, and the water will be taken out to the to some other direction by opening these tunnels. Okay, so this is that view of the Hoover Dam. Okay, you may see many of its video on YouTube as well. Location is USA. This is in USA. Construction completion is 1936, so it's a very old structure, and 165 million is its cost, and the rest of its detail are given over here. Okay. Then we have Bomi Dam, and that is also one of the largest arch dam in the world. Okay, arch dam refers to those dams which are constructed in this curved form. Okay, so its completion time is 1964. This is also a very mega structure, and its power generation capacity is 535 megawatts. Okay, and Sirikit Dam is also one of the example of that mega structure. Okay, you can see it here in the picture, and the rest of the details are given. Okay, and this is Serengeti Dam, and this is also one of that earthwork dam. Okay, if I'm not wrong, its location is Yai River, Yai River, that is in Swat district, okay, in Pakistan. So this is one of their structure. And this is a structure very difficult to pronounce. So this is also located in sub-district, and I'm not much sure where it is located, in the Kanchanburi province. Okay, and this is that year of its completion, and this is the capacity of it, and this is that power generation capacity. And this is another structure, you can see it over here. Okay, that is also one of the example of that mega structure. Then we will come towards the classification of dam structures. on the basis of its function. So that dams may be constructed for storage purpose, maybe for the detention purpose, maybe for diversion purpose, maybe a coffer dam only, maybe a debris dam. Okay, different types of dam structures may be constructed. So let me explain it one by one. Storage dam is actually a dam that is constructed for the storage of water. So in this dam, the main thing should be the concentration on the reservoir. On the downstream side, we should have a large reservoir so that we can store a large amount of water. And detention dam is simply a dam that is constructed for the purpose of slowing the velocity of water and for protection of the rest of the dam. Diversion dam is a dam that is constructed in the across the river so that the water should be diverted from one direction to another direction, or towards some other region of the country, which should be used for irrigation then. And coffer dams are actually those dams which are constructed for construction purpose. Okay, whenever, for example, we are constructing a bridge across a river, so the first step is to construct the foundation, to construct the pile foundations. Okay, and those pile foundation construction, the piers construction, will be done in water. Okay, so that water should be controlled first of all, so that we may be able to construct the foundation of the bridge. Okay, so for that purpose, coffer dams are used. For example, this is that coffer dam in a circular form, and in the middle we will construct that pile foundation for us. This is that pile foundation, this is then the cape, and then we will construct the pier over this. Okay, so this coffer dam is particularly used to control the flow of water in the construction region. Okay, debris dam is actually constructed for controlling the debris to move to the original dam structures. For example, in Turbela Dam, we may construct a debris dam on the upstream side so that the debris or the silt should not flow towards the Turbela Dam to fill it. Okay, to increase its lifetime. Typical storage dams are, for example, this is that typical storage dam in Swat region. This is that typical storage dam. Okay, and this is again that storage dam. Okay, you can see it in pictures. Okay, the names of those dams are also written. Some are very difficult to pronounce. Classification based on hydraulic design. Okay, so the design of the dam may be based on the flow condition, and maybe based on the material. Okay, so then we may have on the basis of material, we have rigid dams and non-rigid dams, and on the basis of the flow, that may we have overflow dam, and you can say that non-overflow dam. Okay, on the basis of the structure of the dam, we are having these types of dams, that is gravity dam. Okay, in which the main load on the dam is that its own weight. Okay, that is its weight in the gravity direction. That's why it is called as gravity dam. So the water that is stored on the upstream side, okay, that will exert some pressure on it. Okay, and that pressure and that overturning pressure, that slipping pressure, will be taken only by this weight. Okay, so the more the weight of the dam is, the more it will be stable. Okay, arch dam, the load is taken by the arch of the structure. So if we see it in the top view, this will be the dam structure, and the water is coming in this direction. Okay, so this arch is giving us stability. And then we have buttress dam. So let me show it to you in the pictures. And then we have embankment dams. So embankment dams, maybe these gravity dams, maybe any other type of dams in which the earth fill is used for that purpose to make the barriers. Okay, so Turbela Dam is one of that embankment dam. Okay, buttress wall, here it is, and these are those buttress walls, and this is called buttress dam as well. Okay, these small walls are called buttress walls. Okay, in which the flow of the river is regulated or divided in small patches. Okay, and these buttresses are constructed for the stability purpose and for regulation purpose. Okay, so here it is. This is that gravity dam cross section. You can see it over here, and this is that arch dam. You can see this is in the form of arch. Okay, this is in the form of arch. So the stability of the dam is based on the arch structure of the dam. And then we have this buttress dams. Then we have, again, this is buttress dam. These are the buttress walls. Okay. Embankment dams, so already I've told you, this is the structure of the embankment, where you can see that the rest of the structure is constructed from the earth fill. Okay, only one core region is present over here, and that core region is also made up of clay. Okay, not anything else like concrete or steel structures may also be used, but most probably we are using here the clay structures only. So whenever we are constructing the dam structures, we will keep this clay layer regularly compacting along these earth fill, okay, so that to rise the level of the dam. And here this will be that condition of the failover. If it is a homogeneous structure, so you can see that the water seepage can be in this form. If it is non-homogeneous case, so then it will be the case, okay, that will be discussed in detail in coming lectures. Embankment dam, so this is again the same thing, okay, shown in 2D view. Then we'll come towards the types of the dams based on the or you can say the types of the dams and its factors that are governing the selection of the types of the dam. So we will discuss it later in the coming lecture. Thank you very much. I hope you have learned something new from this tutorial. In coming a few lectures we will continue the same topic, okay, and that will be again in covering some more aspects of the dam structures. Thank you very much.